Hi everyone. So this is going to be our first math lesson of the school year. During this 4-day week, we are just going to be covering a brief review of fractions. It's something everyone needs almost every year, and it's not going to kill a bunch of time. And since we have a 4-day week, we can just sort of knock it out and then move into the actual algebra. Now, since this is recorded, obviously, you can pause, you can go back, you can skip ahead. Use the video lesson in whatever way it makes sense to you. As far as today, we are going to be covering vocabulary a little bit. We're going to talk about changing mixed numbers to improper fractions and back. We're going to cover multiplying and dividing fractions because they're basically the same thing and they're easy to learn in the same day or review in the same day. And then throughout the whole process, we will be reducing fractions. Keep in mind, these are things you're already supposed to know, would have been taught in 4th, 5th, 6th grade, things like that. But it's the stuff that's easy to forget, and a lot of people do. So that's why we're reviewing it. Also, as we go out throughout the next few lessons, we'll be talking about positive and negative numbers a little bit as we go. All right, so first some vocabulary. So I've got a fraction here, 2/3. You may recall that the top number is called the numerator, and the bottom number is the denominator. Of course, the fraction bar is just called the fraction bar, but it is equivalent to a division symbol. So 2/3 can be thought of as 2 divided by 3. Now, 3 doesn't divide into 2 neatly, so generally you just leave something like that, 2/3. If you do use a calculator to work this out, you get 0.6666, and then it goes on forever. And most people would take this and round off, call it 0.667. And so what we have is the idea that fractions do have a decimal equivalent. Obviously, no new information to you that like 1/2, which is 1 divided by 2, would be 0.5. So again, a fraction is like a division problem. That doesn't mean you actually divide it, but if you do, you get a decimal, and that decimal is equivalent to the fraction. Okay, what we have next, 5 and 1/4. This is a mixed number. So 5 is a whole number, 1/4 is a fractional part. So 5 and 1/4 might be like you bought 6 pizzas for a party and hardly ever no one showed up and only a little bit of the pizza got eaten, so you had 5 whole pizzas plus 1/4 of the other pizza left. Sorry about your social life, but that's the only example I could come up with. Next, we have a fraction where the top number is larger than the bottom number, and this is called an improper fraction. Now, improper doesn't mean bad. It's just the name they gave it. It's okay to have improper fractions a lot of the time, but if the top number is bigger, actually if the top number is equal to, so if you had something like 7/7, that would also be considered improper. So that can happen, and as it turns out, mixed numbers and improper fractions can be switched from one form to another. So we'll be talking about that actually next. So let's look at 5 and 1/4. 5 and 1/4, if we want to make this into an improper fraction, its improper equivalent, what you do is you multiply the bottom number by the whole number, and then you add that result to the top number. So what we have is 4 times 5 is 20. 20 plus 1 is 21. So you write down 21, and then fourths still goes underneath of it. So 5 whole pizzas plus 1/4 of a pizza is the same as 21/4 of a pizza, which is a silly way to think of it. It's mathematically accurate, but that's a good example of how you would not use fractions. So it's a contrived example that doesn't really help with understanding, yet it is still factually true. But 5 and 1/4, or even think money. So in money, a fourth is the same thing as a quarter, which is 25 cents. So 5 and 1/4 dollars would be like $5 and 1/4. Well, that's also the same thing as 21 quarters. If you had 21 coins, the physical coins called quarters, 21 of them, that would be equal to $5 and 1/4 left over. Okay, so mixed number into improper fraction. Denominator times whole number plus numerator. So let's do that. Write that down. Denominator, I'll abbreviate, times whole number plus numerator. I'll divide that, or abbreviate that as well. and then that goes over denominator. So that's how you change a mixed number into an improper fraction. And then you can do the reverse. So 13/5 is an improper fraction. You can convert that to a mixed number. The way to do that is by actually doing physical division, or as some people call it, long division. So let's look at this. Can you divide, well, let's make that 5 look more like a 5. Can you divide that 5 into 1? No. Can you divide 5 into 13? It doesn't go an even number of times, but you can still go in there twice. I mean, 2 times 5 is 10, so that's close to 13. When you subtract that, you get 3 left over. Can you divide 5 into 3? No. This is what we called the remainder back in elementary school. But what we have here with these three numbers, the 2, the 3 remainder, and the 5 we divided by, is if we organize it like this, 2 is our whole number, 5 is our denominator, just like it was over here, and then that remainder 3 goes on top. That's the improper fraction that corresponds to this. I'm sorry, that's the mixed number, that corresponds to that improper fraction. So that long division process is a way to convert improper to mixed number. And a lot of people can do that in their heads. I'm not saying everyone has to be able to, or everyone can all the time, but if you can look at that and say, oh, 5 goes into 13 twice because that's 10. 13 minus 10 is going to leave 3 left over, and there's the answer. So if you do mental math, that's great, that's wonderful. But if you had 529 45ths, maybe that's not going to work out in your head so well, and you're going to want to use a method like that. So mental math is great, but not always practical. Okay, so there's sort of a little set of review notes. Again, you can pause, you can look this over, you can go back, rewatch something. If I really explained something wrong, seek out help somewhere else, or just try to dig through your own memory on this. What I'm going to do today, and what will probably be a habit throughout the class, is following a page or so of notes, I'm going to do examples. So examples are to help you know how to do your homework. What I'm going to choose to do for examples should pretty much always be the even numbers, and then your homework is going to be the odd numbers. So there'll be a copy of this attached into Google Classroom so that you can open it up yourself and you can show your work here and then provide, turn it back in as your homework to get graded by me. Well, you'll actually be grading it yourself. But anyway, yeah, so I'm going to go ahead and do the even numbers. Now, there's 10 of them. If this lesson just drags on and on and on, and you want to skip ahead, I've done a couple multiplication problems, you get it, move on to the division problems, watch a couple of those, you get it, finish the video early and get to work, that's fine. You don't have to watch this whole video, but it'll be there if you need it, and you can always rewatch certain parts. Okay, so here we have our first problem. Hopefully you recall that a dot like that means times. We kind of shy away from the X for times. When I wrote that up here, I was a little leery about using the X for times. We're going to use the dot. But here goes. What is the method for multiplying fractions? And if it's been a while, you might just have forgotten. I'll write it all out once, but you don't need to write it all out like this when you show your work. But the rule is top times top, 8 times 7, and bottom times bottom, 7 times 10. 8 times 7 on top is 56. 7 times 10 on bottom is 70. So that's the rule for multiplying. Top times top, bottom times bottom. Probably all of you can say, oh, 8 times 7 is 56, and you can skip this step. I'm okay with you skipping that. It's not a big deal. When I say show your work, I don't mean you have to show every single detail the same way that I do it when I teach. You're allowed to do it your own style. Just don't copy answers. That's all I want to say. Okay, but that is not the answer. How do I know? Well, I know of 2 ways. One, because I do math for a living. But a second way you can know whether that's the answer or not is you are allowed to scroll down and look at the answers as you go. 4/5 is the answer, and I don't have 4/5. What that means is that there must be some way this fraction can be reduced, and it can be. There's a few methods. One thing, like I said, there's a couple ways to know this isn't the final answer. I noticed that these are both even numbers, and even numbers can be divided by 2. So if you divide a 2 out of both of those, 56 divided by 2. Now here you could grab a calculator if you're not doing mental math all that well. But let's see, 28. So 56 divided by 2 is 28. 70 divided by 2 is 35. But I also know from times tables, 28 and 35 are both divisible by 7. 28 divided by 7 is 4, and 35 divided by 7 is 5. Now I look at 4/5, and there's nothing in common that you can divide out of 4 and 5. So 4/5 cannot be reduced. That would have to be my final answer. And I did already cheat and look at, well, not cheating, you're allowed to do it, but since I already looked at the answers, I know that that was right. So I kind of used the answer to lead me in the right direction. Now I want to get back to showing your work again, because that is a requirement. If I haven't beat that to death enough, I'm going to say it again. You have to show your work. This step is obvious to me, something that you could do in your head. You don't have to write that out. You could go from here to here. As far as reducing goes, if you wanted to write something like this out, you could, but in my opinion, you wouldn't have to do that either. You might just observe, oh, those are both divisible by 2. Grab a calculator, divide them by 2, and you come up with this. Oops. You may or may not know that's divisible by 7, so you have to grab a calculator, again, if you're not good with the mental math, and just start dividing 28 by a bunch of numbers, divide 35 by a bunch of numbers, see if anything works out. And hopefully you'd stumble across 7, you divide them both by 7, and you get that answer right there. So the way that I'm showing work in a lecture is not the way you have to show work in your answers yourself, but if you had this problem and all you wrote down was that answer, I would have an issue with that. So there's got to be some sort of supporting work in between. All right, enough said. Number 4. Now here, before I do anything, I'm going to notice that this is a negative number multiplied by a positive number, and you should know from your years of experience in math that negative times a positive equals a negative. So I know my final answer is going to be a negative. I'm just going to write a negative sign down and then write my fraction bar right next to it. Now I do 2 times 5, which is 10. See, so I'm skipping this step right here just to illustrate that you don't have to show every step when I say show your work, just common sense ones. 3 times 4 is 12. I'm betting that's not the final answer because 10 and 12 are both even numbers, so I'm going to divide them both by 2. So I still have to carry over my negative sign. There's my fraction bar. 10 divided by 2 is 5. 12 divided by 2 is 6. If I look at 5 and 6, there's nothing I can reduce out of those. There's no what we call a common factor. No common factor you can divide out of those. That, I would guess, is my final answer. And I'll go down and check it, just like you can do as you're doing your work. And there it is. So I'm good to go. So now you might be thinking, okay, I think I get the hang of it. I can move on and just do the work by myself. Well, before you do that, maybe look at number 6. These are both mixed numbers. So I am going to change them both into improper fractions before I start. And the first one is negative. So I'm going to write negative fraction bar to represent the first fraction, bring over my dot, and then another fraction bar for my second fraction. Okay, so we have to multiply. 3 times 2 is 6. 6 plus 2 is 8. That's 8/3. 10 times 4, so I did times there. Well, we don't use the x. So 10 times 4 is 40. 40 plus 1 is 41. That's 41/10. Now I need to multiply. Well, bring down the negative, fraction bar. 8 times 41. Well, 8 times 1 is 8. 8 times 4 is 32, so I'd put a 3 and a 2 in front of that. So 8 times 41 is 328. Then on the bottom, 3 times 10, that's easy, that's 30. And let's see, those are both even numbers, so I can divide them both by 2, right? 8 and 0, both even numbers. So bring over my negative sign here. Let's see, 328 divided by 2. 8 divided by 2 is 4. 32 divided by 2 is 60. So 64? No, that's not right. What am I? 16. 164. Yeah, I can do math, honestly. Yeah. And then 30 divided by 2 is 15. Now, this is probably as far as reduced as it'll get. That ends in a 5, that ends in a 4. You know, when things end in 5, you can divide them by 5 and 0, but that's obviously not going to happen on the top there. And, oh, come on. There we go. And since 5 is not an even number, can't do anything there. You could try dividing by 3, but I just know it won't work. So I'm going to say, oh, there's my final answer. Actually, I bet it's not the final answer. Let's look and see. And right there you see that is not the answer, at least as it's written here. Generally, as a rule of thumb, if the problem's given as mixed numbers, your answer should be a mixed number. If the problem was given as improper fractions, it's usually okay to leave your answer as an improper fraction. This we converted to an improper fraction to do the math, but now our final answer has to be converted back. So you remember how to do that? Do 164 divided by 15. 15 goes into 16 once. Subtract that, you get 1, bring down the 4. 15 won't go into 14 at all, which means 0 times 15 is 0. When you minus that, there's a remainder of 14. So that means the answer is negative, because there's a negative sign there, right? Negative 10, which is that number, what we call the quotient, and 14, there's the remainder, 15ths, which was the original denominator, and that is the final answer. So yeah, remember hating to do this in 6th grade or 5th grade or whenever that was. I don't teach elementary school. I don't know exactly when this stuff is taught. I just know that's kind of the era when you learned it, and it was probably not fun for, oh, I want to say at least 80% of the people. So anyway, I'm going to scroll back down, and yeah, there it is. That is the answer. So now it's going to get a little redundant, except, well, I guess number 8 is kind of special because we have a whole number here. So here's what I'm going to do. Negative fraction times fraction. The first one again, 4 times 1 is 4, plus 1 is 5, 5/4. And then 9, you may recall, if you ever have just a whole number, you put it over 1, and that's how you make it a fraction. Negative times positive equals negative. 5 times 9 is 45. 4 times 1 is 4. That's an improper fraction, so now I got to do 45 divided by 4. Notice I didn't bother with the negative sign here. It's not a big deal. I'm just trying to work out the whole mixed number part. So 4 divided by 4 is 1. 4 times 1 is 4. Subtract that, you get 0. Then you bring down the 5. 4 goes into 5 one time. 1 times 4 is 4. Subtract that. 5 minus 4 is 1. So our answer is negative. Now I remember that there's a negative sign involved. Negative 11, that's this number, and 1, that's this number, over 4, that number. So this should be the answer. Scroll down and check number 8. And there it is. So everything that I'm doing, you should know how to do, and you should be able to do on your paper. Again, if you don't show all your work exactly the way I show all my work, that's okay, but you cannot simply have answer and nothing else. So what I do at least, or somewhere in between. I'm going to go ahead and do number 10. You might want to scroll ahead to division if you feel like you get it. If you're not getting it yet, then here's one more example to try to help. So again, we have a negative fraction times another fraction. I need to make these into improper, so 8 times 2 is 16. 16 plus 3 is 19/8. 2 times 2 is 4. 4 plus 1 is 5. 5/2. And so if I multiply here, a negative times a positive equals a negative. 5 times 19, well, 5 times 20 is 100, so 5 times 19 must be 95. 8 times 2 is 16. I don't think we can reduce anything out of 95 and 16. I mean, 16 is divisible by 2, 4, and 8, and 16. None of that's going to go into 95. It ends in a 5, for crying out loud. So now all I got to do is, change it back to a mixed number. So how many times does 16 go into 95? 5 times, what's 5 times 16? That's 80. Yeah, I'm going to say 5 times. 5 times 6 is 30, carry the 3, 5 times 1 is 5, plus 3 is 8. Subtract those, 95 minus, yeah, it's 15. 15 smaller than 16, so there we go. Don't forget the negative sign. 5 is the whole number right here. 15 is the numerator, that number, and then 16 is the denominator. Oh, let's hope that's the answer. It's really embarrassing when I make these videos. I go through all this work and I scroll down and I get a wrong answer. Hopefully that never happens. And there we are. That's when I stop recording and go back and start the whole thing over again. Okay, now we're into dividing. Find each quotient. Quotient means the answer to a division problem. So we're supposed to divide these. Okay, so the theory behind dividing is that when you divide by fractions, it actually can be changed into multiplying, and it'll still work out. The trick is you have to keep the first fraction the way it is. You have to change the multiply or the divide to multiply. Then you have to flip the second fraction over. So every time you do one of these problems, you're going to keep this the way it is, change that to times, and then flip this over. Oh, by the way, notice a negative sign up here I just brought out in front, and that's okay. A negative fraction, usually the negative is in front of the fraction bar. It can appear in just the top. It could even appear in the bottom. You shouldn't see it in the top and the bottom, though, because two negatives cancel out, make a positive. So that's almost never a thing. But like what I did here, you can just bring the negative out front. Okay, so anyway, I did the keep, change, flip. Now I'm just going to repeat the work I did up above. So our answer's got to be negative. 1 times 4 straight across gives me 4 on top. 2 times 5 on bottom gives me 10 on bottom. 4 and 10 are both even numbers, so I can reduce that by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. Negative 2/5 should be the answer. Let's see. And there it is. Let me go back to that reducing again for a second. Ooh, scrolling up and down so fast might be giving you a headache. Where am I? Okay. Maybe I should do this every once in a while just to maintain some clarity. So to reduce this one, I divided both of these by 2. And that gave me, oops, negative 2 on top, 5 on bottom. There's the answer. Okay, I do want to deviate from this for just a second and show you a bit of a shortcut. Shortcuts in math are interesting. They can be either really helpful or really confusing. And it's always risky as a teacher when you teach a shortcut that, you know, the rewards could be great. Everyone could catch on and it could make life a lot easier. Or people could just not catch on. It could be confusing and then you've just ruined people's brains, which you never want to have happen. But anyway, you might already know this. So here, what am I doing here? I'm redoing this problem. So I did the keep, change, flip again. But before I start, if you notice that the 2 on the bottom over here and the 4 on the top over there, they're not in the same fraction, but in a multiplication problem, it really doesn't matter if they're not in the same fraction. You can reduce ahead of time, like pre-reduce your problem. Actually, it's not called pre-reducing, it's called canceling. So you can cancel this 2 in that 4. 2 goes into 2 once, 2 goes into 4 twice. Now, if you multiply this, you got to bring over your negative sign. 1 times 2 is 2, 1 times 5 is 5, and there's the final answer. Since we reduced ahead of time, we didn't have to reduce now. So that pre-reducing or canceling is a shortcut. It's a tool you can use if you find that it makes your life easier. You don't have to do it. You can do it this way and still get the right answer. But I am going to go back up and say that on a lot of these problems, I could have done the same thing. In fact, on this very first problem right here, number 2, I could just cancel this 7 with this 7. 7 goes into 7 once. And then 8 and 12 are both even numbers. So if I divide them by 2, I get 4 and 5. Now look at what I have. 4 times 1 equals 4, and 1 times 5 equals 5. And there's the final answer. Same answer. And as far as, you know, how do you show your work? You just draw some little lines through them and then cross things out. And then there you go. So use canceling if you find it helpful. If not, just do it the way that I've been teaching you. Which leads me to number 14. Okay, so can I cancel this 2 into this 8? 2 goes into 2 once, 2 goes into 8 4 times? No, you can't. Because canceling only is something that's allowed during multiplication, and this is still division. To change this to multiplication, you keep, change, flip. Ooh, what is that? That's supposed to be an 8. And once it's flipped over, Now the 7 is on top. 2 does not cancel into 7. 1 technically does cancel into 8, but all you're left with is a 1 and an 8, so it doesn't make any sense to do that. You can't cancel straight across. That's not allowed. It has to be a top number with a bottom number. So this does not cancel. You just have to keep, change, flip, and then go straight to multiplying. 1 times 7 is 7. 2 times 8 is 16. But if it didn't cancel, that means it won't reduce. There's no extra steps at the end. 7/16 is just the final answer. Okay, number 16. So this is a mixed number and a whole number. So I need to change it. Negative fraction divided by fraction. Okay, 9 times 3 is 27. 27, 28, 29, 30, 31, 32. 32 ninths. And you couldn't see that, but I literally did count on my fingers just now. The number 3 turns into 3 over 1. Now I need to do my keep, change, flip because it is still divide. So keep this 32 ninths, change divide to times, flip to 1/3. You cannot cancel the 3 and the 9. They're both on bottom. 3 won't go into 32, which means all I could do is multiply this out. Negative times positive equals negative. 32 times 1, go straight across, is 32. 9 times 3 is 27. Now, since it didn't cancel, this is not going to reduce. You can think it through, like 32 is 2 times 16 and 4 times 8, stuff like that. 27 is 3 times 9. There's no numbers in common out of any of these that are going to cross out. So there is no reducing. All we can do now is change it back into a mixed number. So 32 divided by 27. Well, 27 only goes into 32 once. They're really almost, they're close to each other. 27, so when you subtract that, borrow 12, that's 5. So negative 1 is my whole number. 5, the remainder. 27 is the denominator. That should be the answer to number 16. Now, if you're saying, I wish he would slow down, there's the answer. Yeah, I kind of get that way in a live class too, and I encourage my students to holler at me, tell me to stop, slow down if I get going too fast during a lesson. At least here you can pause it, you can think it through yourself, you can scroll back a little bit and rewatch it. You can slow down the speed if you want on YouTube. It makes my voice sound funny, but it's probably already a goofy voice anyway, so yeah, keep all those tips in mind if I ever just go too fast through something. Okay, here we're getting pretty repetitious, so like I said before, you can just stop the video and move on to the assignment again. You're going to be assigned the odd problems. Finish watching if you need to. You're obviously welcome to. So, yeah, let me go ahead and do this. 1/9 is a proper fraction, no problem there, but this one, this negative 1 1/3, so I multiply 1 times 3 is 3, 3 plus 1 is 4, so negative 4/3. Now I do my keep, change, flip. Looking at this, I see that 3 and 9 are reducible, so I'm going to cancel. If you divide them both by 3, 3 divided by 3 is 1, and 9 divided by 3 is 3. Now to work this out, I do have a positive fraction times a negative. Positive times negative equals negative. Multiply top times top. 1 times 1 is 1. Bottom times bottom. 3 times 4 is 12. 1 and 12 cannot be reduced. You can't reduce a 1 with anything. And there's the answer, negative 1/12. We're up to our last problem. Let's just peek. All right, so my final answer is supposed to be negative 1 and 29/45. We'll try and keep that in our short-term memory as we go through here. Okay, so now I need to make both of these into improper fractions. 10 times 3 is 30. 30 plus 7 is 37. 37 tenths. 4 times 2 is 8. 8 plus 1 is 9. 9/4. Now I do my little keep, change, flip. So negative 37 tenths. Change this to times and flip the second one over. It's always the second one. Now, do you see anything that will reduce or cancel ahead of time? I see a 4 and a 10, which are both even numbers, so I can divide them by 2. 2 goes into 4 twice. 2 goes into 10 5 times. So when I multiply this out now, I do have a negative times a positive, so that's negative 2 times 37. 2 times 30 is 60. 2 times 7 is 14. 60 and 14 is 74. 5 times 9 is 45. That is improper, so I need to do 74 divided by 45. 45 goes into 74 once. 45 and minus that, borrow. 14 minus 5 is 9. 6 minus 4 is 2. So what's my answer? I've got my negative sign I need to bring down. Oops, don't want to do that yet. 1 is my whole number. 29 is my numerator. 45 is my denominator. And we peeked at the answer ahead of time, and that is what we expected to get. So, okay, you are now asked to do the odd problems. You can download the PDF that has this information on it, work it out, attach it, and then send that to me through Google Classroom. You attach it when you submit it. You can work it out by actually writing on the screen with your finger, with a stylus, whatever works for you. Or you can print this and then show your work on the paper. Use a pencil, hopefully not a pen. Or if you don't have a printer, you can just grab a sheet of notebook paper and do these problems on your notebook paper. Take a picture of your work when you're done, attach that, and then submit that as your assignment. Do check your answers, and for about the 1 billionth time, don't forget to show your work. All right, if you have questions, email me or post them in the comments of Google Classroom, and I will talk to you later.